Now that we've written a custom dependency resolver, let me give you an example of how useful it can be. Inside the home controller, we're constructing an instance of a class called SMS Messenger and invoking a send message API. If this class actually talks over the network, I have a bit of a testability problem because I could have tests fail just because the network's not up. And it's very difficult to find out what exactly we sent over the network when I'm using a class like SMS Messenger. I've also tied myself to a specific type of messenger. What I would prefer the home controller do is actually just program to an interface. iMessenger, it defines a send message method. Now I can have different types of messengers that talk to different types of destinations, and I can have a fake messenger that I use in my unit test that makes the controller easy to test. And furthermore, I would like for the home controller to accept a messenger as a parameter to its constructor. So you give me an iMessenger, I will save that off into a field, and now my controller doesn't have to worry about constructing a messenger. It's just going to use the messenger that was given to it. This is dependency injection. Unfortunately, here's what happens if we do not have this dependency resolver in play. I'm going to do a build, and I'm going to come out to the view and refresh it, and we'll get the exception, no parameterless constructor. So the default controller factory in ASP.NET MVC is trying to construct a home controller, but it will only construct controllers that have a default constructor or a constructor that doesn't take any parameters. To fix this problem in MVC2, we'd have to go out and implement a custom controller factory. We'd have to plug that controller factory into the MVC runtime. But now that we have a dependency resolver, we can actually do this right here inside of our startup method. You see, all these IOC containers like structure map and ninject and unity, if you give them enough information about an object, they'll be able to walk up to a concrete class like the home controller and see that, oh, I'm looking at your constructor parameters and you need an iMessenger. Well, it just so happens that someone has told me that when someone needs an iMessenger that I am supposed to hand out an SMS Messenger instance. That single line of code has given Ninject enough information to construct a home controller for us. And because the MVC framework calls into our dependency resolver to see if we can build a controller for it, then we're going to be able to build this home controller. Let's open it up and actually put a breakpoint here inside the constructor and run this application with debugging. Now remember, we also had a breakpoint inside of get service. Right now the MVC runtime is looking for a controller factory, it's looking for a controller activator, and right now it's trying to say, can you build a home controller for me? Do you have that service? So let's step into get service, and we're going to invoke kernel.tryget, and notice that now we're inside of the home controller constructor. The kernel, or Ninject, is building this controller for us. It knows that it was supposed to pass in an SMS Messenger for us. And if I press F5 and remove the breakpoint that we have inside of get service, what we'll see is that the view again renders successfully. The end result is that with very little work, we've been able to inject dependencies into our controllers.